Okay, hopefully we're making some progress. We are pre-AP chemistry from Allen High School in Allen, Texas, working on formula stoichiometry, building up to really what is true stoichiometry, and that's reaction stoichiometry. Now, at the end of your notes, you have this little map, and I would suggest getting this map out and using it to kind of do a check of where we are at each step along the way now. So far, what we've been working on is mass and moles use molar mass. Remember that term molar mass counts for formula weight, atomic mass, formula mass, all sorts of different things, okay? Now, what we're going to do now is get back at that count, the counting of particles. When we're talking about numbers of formula units, numbers of molecules. And when we are doing that, I know you can do this because when we're talking about the count, we're talking about Avogadro's number. So let's take a look at some problems here. So this question says, or asks, how many formula units are there for every 7.55 moles? I'm not dealing with mass anymore. A formula unit is a count. And so when we're counting, we get to use Avogadro's number, 6.02 times 10 to the 23rd of anything. In this case, we have formula units. That's equal to 1 mole of formula units. So we're going to start with our given, 7.55 moles. Now we're going to multiply it by our conversion factor. You must use dimensional analysis here. I have moles in the numerator. I want to eliminate moles, so I put them in the denominator. That way those two units will cancel. And I want formula units. Again, notice that the 1 is in front of the mole. The mole is number 1. So whenever you're going from the mole to anything else, okay, for now, put the 1 in front of the moles. Unfortunately, later on, it won't be true. But for now, if you're going from mole to something else, the 1 will go in front of the mole. Now, I think what we're going to have to make sure of when we get into class is a reminder that when you're doing scientific notation, that whole times 10 caret business is your EE or exponent key. We'll have to practice that again. So I'm going to go to 3 sig figs since that's what my original had. And I have 4.55 times 10 to the 24th formula units. Yay! So this would probably be a 1 point, maybe a point for units, and maybe a point for math and sig figs. So maybe a 3-point question. Sometimes when it's only a step, we put them in multiple choice. All right, again, so we've got question mark moles are equivalent to. And this time we're talking about molecules. And the only reason we use the word molecule is because it's covalent. Water's covalent. So if you look back at your math, we've got a 1 step. Moles to a count. When it's moles to a count, we use count Avogadro's number, which is pretty big, so I'm going to leave myself lots of space there. All right? We put our given first opposite the question mark. So I've got, whoops, I guess I should have given this more room, 8.24 times 10 to the 26th. Now, often at this point, I have students who ask me if they can use kind of the computer notation for that, and my answer used to be no, but it doesn't bother me so much anymore. We pretty much know in terms of communicating symbols what that symbol means. So that's molecules. I want to eliminate molecules. They're in the numerator, put them in the denominator. I want moles. If you look at your map, this is a 1 step. So if we go back to this map, we are here. White on white doesn't tend to work there. We are here, and we're just going 1 step to here. Okay, so it really does help to find your way on that map. You know, throw down that map at the top of the paper right next to Brinkelhoff, I bring clay. All right, so now we've got the 1 in front of the mole, and we get to use 6.02 times 10 to the 23rd for Avogadro's number. Be very careful. You're not putting this number in front of the mole. It goes in front of whatever you are counting. Remember, you can do this with count Avogadro's number. And if we did that math, we get 4 point, whoops, I'm looking at the wrong problem here. Sorry about that. 1.37. 1.37 times 10 to the 3rd moles of water. All right, forging ahead. I hope you're kind of picking this up here. So we've got our question mark. How many formula units are equivalent to 0.75 moles? If you look on your map, we're counting. So when we count, we get to use Avogadro's number. So we have 0.75 moles. Now, I want to eliminate moles. They're in the numerator. I put them in the denominator. Now, since this is ionic, technically this is considered a formula unit. Okay, so 1 mole for 6.02 times 10 to the 23rd. Now, be very careful to double check that your units cancel and that the 1 is front of the mole and that Avogadro's number is in front of the formula unit or the molecule or the atom, right? And if we do that algebra too, we really should have just 2 sig figs here. So I'm going to put 4.5 times 10 to the 23rd formula units of NaBr. In this case, if you couldn't write that, we were okay because we didn't need the molar mass, which is what we would need that formula for. All right, let's keep going here. Now, question mark moles are equivalent to molecules, which is a count. It's only when there's a count that you can use count Avogadro's number. So, we start with our given, 4.55 times 10 to the 24th molecules, because carbon dioxide is covalent. Molecules are in the numerator. I want to eliminate them, so I'll put them in the denominator, and I want to go to moles. Now remember, find the counting unit. That's where count Avogadro's number will go. 10 to the 23rd is a count of molecules for 1 mole. And to 3 sig figs, that should be 7.56 moles. All right, now we're going to put them into 2 steps. We're going to put together what we did in the past. So we're going to do the grams and the count. And I do not teach this as a single step. I always teach this as a double step because I'll mess up, I'll flip-flop, and you will likely flip-flop as well. So let's go ahead and sketch out our map. So our particles go up here, whatever we're counting, atoms, formula units, or whatever. And then we go to the heart of chemistry, which is the mole, and then we can go to mass. Now, if you can, sketch that out, map where you're starting, it will really help. So let's do a couple of these. So we've got particles to moles, moles to mass. All right? So it says question mark atoms. How many atoms are equivalent to 13.2 grams? So find your question mark. We always start with our given. Now, we are here on our map, and we want to get to here. Atoms, this is pure iron, so we can do this directly, but it's going to take 2 steps. We never bypass that heart of chemistry. We're going to do this in 2 steps. Set it up as a railroad. So we're going to have 1 step, and then we will have the 2nd step. Now, we'll start with our given. We have 13.2 grams. We want to get rid of grams and go to moles. We always want to hit that heart of chemistry. Mass to moles use molar mass. We get the molar mass from the periodic table. For every 1 mole, the periodic table tells us that we would have to measure out 55.85 grams of iron. So now we've made it one step. We're not done yet. We need to eliminate moles and we need to get to atoms. Now remember, atoms is something we count. That's where count Avogadro's number goes. Okay, Avogadro wasn't really a count. But ever since we started putting the count from Sesame Street, and I started using that phrase, it's really helped students a lot. So I know it seems silly, but the repetition will help. You want to go back and you want to double check your units cancel. Otherwise, you might end up with grams squared over moles squared or something funky like that. You got to be very careful. And if we did that algebra, I'd get 1.45 to 3 sig figs, because that's what our original has, times 10 to the 23rd. Remember, we're talking about pure iron, so we're talking about atoms. That's our unit in this case. You have to include that or you'll lose points. All right. Now, I want to do another couple of 2 steps, and then we'll do a few challenging one in the next videos. All right. So you have your map. We've got how many grams? So we've got question mark grams are equivalent to, you'll see why I left myself a gap there, 6.25 times 10 to the 25 formula units. Now formula units is a count. Now I can't go directly there. First I have to go from grams to moles, and then I can get from moles to my count. I will set it up with parentheses this time. So it's 2 steps, 6.25 times 10 to the 25th formula units times, I want to eliminate formula units because it's in the numerator, and I want to get to moles. Avogadro says for every 1 mole, there's 6.02 times 10 to the 23rd formula units. Now that's one step. I've gone from formula units to moles. I have to take the next part of my journey. Now I have to eliminate moles, move away from moles, and go to mass. Mass to moles use molar mass. Now, sometimes we give that to you on the test because at some point it just takes a lot of time to calculate every molar mass, and once we've seen it, you can do it a couple of times. That's plenty for us. Other times we'll ask you to write it, and that alone would be worth a point. Magnesium is +2, chloride's -1, so it'd be MgCl2, and the periodic table tells us for every 1 mole we have 95.21 grams. And if we do that math, 9.88 times 10 to the 3rd grams of magnesium chloride. All right. Now, some of the ones that we have are including pounds and doing a conversion factor with pounds. So in the next video, I will start out with just one of those. I'm not going to do every one. I think I've done enough that you should get a good hang of this. I'll do one more as a review at the beginning of the next video. And from there, we will move on. So until then, this is signing off.